meet you all. I hope you had a nice day. I hope with much to learn. And now in the evening time, you will learn a little bit more about the very essential things in your future career, because data is the new oil, gold. There are so many, right? So many explanations, but is that true? Is data like oil? Is data like gold? What do you think? Yes? Is there anyone who says no?
Depends on the data what you have. If you have a lot of published data, it can't really.
Very good. And there's another difference.
What you make out of it.
Sorry?
What you make out of it.
Yes, what you make out of it, because only data is nothing. It's a waste of platinum and storage. Yeah. There's another point. You need humans. Very good.
The limitation.
I would say it's the other way. Gold and oil is limited, at least on this planet. But if you have data, we create every day new data, and you can connect it with other data. And the value comes from that you connect data with each other. So I think data is more than only gold or oil. It's not limited, and it's up to us what we do with this data. We need humans to make valuable things with it. We need frameworks that the results are usable for the companies or for other humans. And so we are here today to talk about what we need to do with data so that we can have very big benefit from it in our future company, in our future career, and hopefully the whole humankind. So my name is I studied in the 19th mathematics in connection with economic and data science. It was a pretty new study in that kind. Today it's normal to have data science in mathematics or economic studies, but in that time it was pretty new. So then I joined big consulting and professional audit companies and learned how many problems IT can occur, and that you need to audit these systems and especially audit the data that comes from. And nowadays, I started my own company in 2020. I have a whistleblowing platform which detects or identifies valuable hints in reporters' reports. We use artificial intelligence for that, and we need to do this in a very sensitive way, because in every company there are so many data, and we need to protect the really sensitive personal data from the employees. So Sanja, who are you?
So hi, my name is Sanja Jovanovic. I maybe might not have so many years of experience, but I studied information systems actually at the Business University of Economics in Vienna. But for some reason, I found IT very, very interesting, and slowly it moved towards data science. I spent half a year of focusing for my master's thesis, looking into the data sets of an insurance company and trying to figure out how data science can help in that domain. And then basically I started to work as a so-called cloud solution architect at Microsoft, which is basically like an IT advisory for different customers in different domains, which was super interesting because it's not, it's not so deep into one domain, but you rather see tons of different, companies and see their challenges and basically learn along the way. And recently, I joined a company called Databricks, which is more in the big data platform side and also integrates with giving you the technology and tools to do machine learning in a distributed way, meaning that you have so much data that you cannot really work with it on a single machine, but you rather need a parallel system to kind of distribute it and make it faster to process. And I'm there for, I think, 5 months now. I actually just came from Munich, so kind of moved there as well. It also says in my free time, I like to travel. That is indeed the case. It was a bit boring during COVID, but I think everybody who kind of familiarizes with it feels me. And other than that, I started sailing last year, which is still a process to go. But I think with all the nice lakes in Austria, it's kind of really cool to do that. That's all me.
And there's another thing what you are doing in your free time. We are both
women in AI, right?
Yeah, so we are both in the board of the local foundation of Women in AI, which is a worldwide network, and we would like to encourage more females, more girls, more women to join the MINT studies, and actually we hope that more will program in the area of artificial intelligence. And we hope with our encouraging, we will bridge the gap of the not so many female data which are used to train the artificial intelligence. But we will come on that point a little bit later. So, what's on the agenda today? So first of all, let us look why so many enterprises are struggling with data. Then have a look on the complexity of data and IT systems. So where comes the complexity from? So in my opinion, it's a wonder that all these IT systems are working so good together, because if you have a look behind all these things, there are so many really complex processes which are running on so different hardware. But we will talk in a few minutes about that. After that, we will have a look on the data governance and audit. And I think that will be a very big point in your future career. So if you don't have very good data governance processes in a company, you will never have good data. And you can never use it for your future business models. Then we will have a look on the different types of data, or kinds of data. So there are very specific data, and you need to know how to use it and who will be the owner of this data. And these data are in every company, and you will need it in every project you will do. And projects is the next point. So until I would say 5 years ago, we have these traditional IT projects. And since the last 5 years, we started with these big data projects. But what is a big data project? We will have a look on all these things and discuss together how we use this for the benefit of the company. And last but not least, we will have a small use case together, how we can use data in a specific field. If you have any question, you can ask us anytime. Oops. So, what makes Zalando so a big player in the market in few years, Zalando is one of the biggest online shops of the world. What do you think? What makes it so successful?
Does everybody know Zalando, right? Yeah.
Not only the female. So what had Zalando done differently like other companies? So they focuses on the user experience. So they don't say, okay, let us sell any shirts or trousers. No, we will have the best user experience for everyone who comes on our marketplace. And for the developers, they don't care if they sell any sweater, if they sell a shoe. It could be a license for software. It could be insurance job. They don't care what they sell, but what they would like to do is make the best experience for the customer. And this is where they started. And they have a mentality, use every information they can get from the user who's currently on the platform and give them the best experience they can have so that they will buy as much as could be. Yeah, so that's the difference. It's a complete different starting point. Other companies say, okay, we sell food or we sell shoes. Yeah, Zalando said, we don't care what we sell. We have data from past customers. We know what the customers like, and we will use these data to give the future or the current customers the best experience at shopping they can have. And this is why they are very successful.
Before moving on, just out of curiosity, like what kind of use cases do you think they're using? Like what kind of data, what kind of applications are they using for their whole data science journey? Like everybody knows Zalando, right? And you're using the app, maybe you're browsing through, like what do you think are the aspects that they're having? Any clues, any ideas? Go ahead. Just.
I mean, what does they distinguish from other companies like Amazon? I mean, they collect the same data basically, and they also focus on user experience. And where is the USP in user experience compared to other platforms? I cannot see point.
Amazon is much like broader in the product. Zalando is more on like clothing and trends and things like that. So you wouldn't be, at least I don't know, you wouldn't be able to buy a toaster on Zalando unless I'm wrong. But at least I use it for like clothes and like accessories or things like that. So the whole trends basically. And Amazon is more, you can find anything, right? If you search for a T-shirt for your bachelor party or whatever, you can find it there. If you search for,
it's more the matching in the broad. So if you bought this book, for example, you might be interested in a game too. Huh? And at Zalando, they try to give you a good experience. So they try to sell you a trend. So they know if he will buy black trouser, for example, he might be interested in a specific shirt, for example. Yeah? So they are really very special in these kinds. So it's a niche, and for Amazon, it's more in the broad. So they would like to sell everything what's in the world on their platform, and they try to connect all these data together and try to find out if someone has bought this book, he might be interested as well in additional accessoires or something like that.
Okay, but anyways, like the data and the use cases we'll explore later on as well as like the closing. But I was just like curious if you have any idea what could be used in the data science or machine learning domain that they're using.
Yes, how you navigate, how long you need or which pathways you use and navigating.
Yeah.
They might use like next best offer. That's maybe that they want to do, or maybe they try to know which size they need.
Mm-hmm. Good. Already some of them will be mentioned later on, but yeah, great. Cool, that's my slide. Okay, so now moving on, so we heard about Zalando, but if you kind of generalize it to other companies, we already heard that like most enterprises struggle with data. It's the complexity that adds like an additional layer on top of like anything basically that a company does. And if you look at that slide, it kind of looks very structured. At first sight, you have different use cases or different applications. You have the data warehousing on the left, and it kind of slowly moves to the right with data science. And just heads up if somebody does not know what streaming and data warehousing is. Just okay, yeah.
Please explain.
Okay, cool. So data warehousing has been there for, I don't know, 40 years or more. It's basically the fact that you have different databases from different departments. Let's say, I don't know, marketing has something, I don't know, HR, sales, and the rest. Everybody has their own kind of set of data. But at some point you want to aggregate them or like store them in a centralized place. And this is where data warehousing comes into play. So it's like this storage layer that combines all these different data sources. And then in the end, it's used to kind of create an additional abstraction. For example, it's called views or marts, basically to give it over to a business unit, for example, I don't know, sales or to a manager to kind of investigate what has actually happened. So this is more the reporting side, preparing the data and combining all these different sources. The thing with like data warehousing is it's all based on structured data. And what structured data is, we'll go into, but in a nutshell, it's basically the data that you can put into like columns and rows. So it could be customer data with the name, address, and things like that. The problem with the data warehousing was that once like streaming came into place, or once you wanted to add some like IoT use cases, so adding sensor data or adding like additional data like the clickstream that you mentioned before, it's kind of tedious. It doesn't really work. It gets really expensive. So people or like enterprises kind of use the whole concept of a data lake, which means that it's a super cheap storage where you can put in like any kind of format that you have. It does not need to be structured. It can be images, it can be voice, like audio, anything basically, binary data, even like the virtual machine images. So anything that you think of, you can just like put it there, and it's super cheap. And this kind of allowed use cases like streaming. So basically being able to have real-time information. Let's say you have a smartwatch or so, and you want to make sure that if something happens, it's kind of you get an alert. Or better said, in manufacturing, there are machines that are having sensors, and in case something happens, you want to be able to have a notification that something just happened. So basically, this is the whole streaming part. And data engineering is just the fact that you want to analyze and like prepare the data from all these different sources. So not even structured, but even unstructured, to make sure you have it available, for example, for the data science part. So there are much more, but this is like the evolution of data, I would call. And there's actually another part as well to that, but later more. But as you see, it looks very, very kind of structured, more or less. But if you go further, what you can see is that basically all these different applications, it's much more in the back end. It's not only that you have these few databases that need to be connected, but rather there's much more. So teams, for example, they share their data, not in a proper way, but I don't know, everybody knows Excel, so just like send it over the email, data gets duplicated, and everything is like much more complex than it might seem at the beginning. And then on the second layer, what you can see is basically that you get additional complexity through systems. And everybody who also heard about cloud knows that like whatever you want to do, there's like, I don't know, 50 different tools that you can use for that. And this is actually also in companies, because like, for example, one business unit wants to use that software, the other wants to use that software. So it gets like really, really complicated in the end. And if you go further, the next challenge on like this visual graph is basically that all these different personas who work with the data are also like really in their silos. So a data analyst who is using the data to kind of create reports. So for you as a manager at some point, they're only like in their view. So they don't see much what happened at the, I don't know, data science stack, for example. And the same is actually on all the other parts as well. So it kind of really adds much complexity about what data structures they are and how to integrate that. And as Gabi said at the beginning, you're super like, it's interesting that all these systems actually work together, and actually it is like that. So, yeah.
So let us have a look on the complexity of all these systems. So we have 5 components. So starting on the right side, we have hardware, we have very, very wide difference hardware, we have the smartphones, we have a desktop PC, we have laptops, we have different servers, we have the hardware from different manufacturers, which are working a little bit different, so that the operating system manufacturer need to implement specific things in their software. We have now cloud systems, so this works a little bit different to servers and the normal database servers. And all these different hardware need to be served by softwares, because without software, this would be only like a stone. You cannot do anything with it. It's more than art. You can put it on the, not out of the window, but you can put it on your shelf and you can have a look every day. But it would not be useful. It's only hardware. So you need software to make it useful. And it's not only one piece of software which runs on the system. So we have different layers of software. And these different layers are connected between interfaces with each other. And these interfaces are produced by different developers. And what do you think? What means that different developers have produced this software? Everyone creates its own university. Yeah? Everyone has their own ideas. Everyone has a good idea how we can solve a specific problem in the software. And every software is a little bit different, and it needs to work on every hardware for which it was developed. So this is for its own very complex, but we have another complexity. We have data, because if you have software, it would be fine. It runs on a hardware, but it would not be any useful. You need data to make the results of the software useful for you or for the company. Think of all your apps. Without any data, it would be nice to have these pictures. It's funny pictures on the smartphone, but you cannot use it. You would not know from which station to another station runs the YouTube. It's only pictures. So you need data, and these data must be structured in a specific way so that the software can useful work with it. If you don't have structured or the data in a specific format, you cannot use it with your specific software. So if you, as a user, give your data into the software, you need to know these rules, how the software works, and you need to give the input in exactly that way. So otherwise you wouldn't have no useful result. So that comes to another point. We have different user, because when the data is there, you need users to make any steps, to give it as an input in the system, or to click on a button so that other magic things occur. So you need user who work with the system, not only with the software. No, it's the data too, and it's very useful that you as a user exactly know how the software, which thousands of other developers has made, need the data. Otherwise, you give data in, but you don't know which data. For example, if there is a field which needs as an input a date, you might know which kind of date. It could be the date, the first of the month. It could be the date, the last of the month. It could be the date where you have your birthday. But if you don't know which day should be included in that field, you will not be able to give it in the right way. And if you put in the data not in the right way, the software cannot work properly. Yeah. And then we have the fifth step of the complexity. We have, for example, different laws which needs to be forced for the marketing team, or needs to be forced in the production. Or we have the data protection guideline, which was implemented in 2018. So everyone or every company needs to follow all these data protection rules. And all these things needs to be followed from a system which was prepared by a user who don't know all these law requirements, and was developed by developers in, let me say, in China, which don't have all these kind of rules we have in the European Union. So this is where all this complexity comes from, and you need to ask at every step when you implement a new system in your company. So what do we have for a hardware? Can they work properly with our software, which we would like to have? Yeah? Do we have the data which comes in the software? And do we have the proper or the best ausgebildet, sorry. The best trained people in our company, so that we can work with this software, and have we follow all the rules? Not only the law, it's company rules, it's guidelines, it's standards. And in some cases, some companies needs to follow not only the rules of, in our case, Austria, they need to follow as well the rules of the US, of the United Kingdom. And that can be, in some use cases, very, very tricky. So at the end, the hardware and the life of our IT systems are only, the picture of us depicted. So there are only, is there energy or is there no energy, or 1 and 0? This is all what the hardware can work with. Yeah? And we need to implement in a whole process the real world, which comes with laws, which comes with very specific requirements from our customers, for example. Yeah, we need to work with very specific and sometimes good, sometimes not as good trained people, with so many and tons of data which we have already in some of our data warehouses or databases. And at the end, all this hardware can do is see if there is on one place energy or if there is no energy. So this is where all this complexity comes from.
Okay, so and then there's the fact, or like the myth that somebody says like, oh, okay, I have data and I want to do AI. So basically I want to do some data science on the data because I have data. And then if you look at that, and this is actually taken from a Google research paper, if you look at this image, it's basically the ML code is in the middle, and this is the size of time that you need for the whole like data science part to be developed. But the rest is like the whole time-consuming part that every project has basically. It's the data configuration, it's the data like creating data, accessing data, data quality. It's all the processes and the tools that you need that Gabi just mentioned to kind of integrate it, to make it accessible, to make it autonomous in a sense that your team develops something and then they kind of have checks or tests internal, and then it's deployed. And deployment is another fact that is really like time consuming and needs a lot of effort as well, because in the end it takes not only the data scientists to do that, but you really need to integrate other teams as well in order to make that thing, whatever you develop, make it work. And in the case of Zalando, if that is, for example, like predicting the sizes, what we heard before, it's really not only accessing the data or like getting the prepared data from, for example, the data engineers, or like training the model from the data scientists, but also like really integrating all these different people as well in the team to make it work in the end. And whoever says to you like, oh, okay, let's do data science, we have enough of data, which I actually had like a call a couple of weeks ago. It's like much more to that, and not only using a machine learning algorithm and then just like passing it through, because the technology is there. There's so many advances, there's so many method that you can use out of the box, even like train things from Google or from other companies or like big players that you can take and then put additional layers on top of that to make it work for your data. Technology is there, but the rest is the mess basically, and the things where really like the whole complexity, I would call it as well, comes into. And I just like yesterday came back from a customer event as well, where they tried to use their data, and they had, as we showed before, they had like this old legacy system. It was like a machine, and the machine gathered some sensor data. And then basically what they wanted to do is integrate this data with like another data set that they had, which was more accurate. But like the first challenge that they had, which should have taken like 30 minutes to integrate, it was like the whole day to make it work, because like the timestamp from that system was different to another, and how can you find a way to kind of merge it? So as you see, AI or data science is not like something that you just like feed in and you get something. And as somebody also said, garbage in, garbage out, to make sure that we all start with the data. And even though the course is data science for management, I think it's super important to understand that the data aspect is one of the most important parts, and then also working with the people. And it's super interesting paper for those who want to read.
So who has a little bit experience with artificial intelligence? Come on. So what do you think is artificial intelligence? What is your feeling about artificial intelligence? Are you thinking of the Terminator? Anyone?
Statistics, data points.
Very good. Data points, yeah. Someone? So I totally agree with you. So artificial intelligence is, more or less statistic. And you use data with statistic models, and you feed them. And in some of the artificial intelligence methods, you let to train them and do some things for themselves. So if you will use it in future times in your company, you can think of it as a new fellow. So it's a totally new employee, and you need to teach them how he should support you in your business processes. So as a new employee, you need to train him with your specific business data. And you need to identify which data will bring the most value to train the system, the artificial intelligence. Yeah? And you need to identify further on if the results which the new employee AI is bringing, if they are in your business model or if the business model is not best supported. So as you see, the machine learning code is a very, very, very small thing in this whole framework, which you need to implement in your company to use artificial intelligence and data with artificial intelligence very proper and successful. And you need to monitor it, yeah? Because the system will bring you a mathematical proper result every time. Yeah? The results will come from a statistic model and it will be mathematic correct. But if you need other results in your business model, that's on the others page. Yeah? We'll come to that point back a little bit later, but keep that in mind. Every machine learning code will bring you a mathematically correct result. But if you would like to have this result or another result, that's the question. Because it brings you every time a right answer, but be sure to give them the right question in front of them.
And on top of all the complexity and all the aspects that we just talked about, one thing that for sure you as business decision makers will see is the data governance, and this is especially important in Europe with the whole GDPR things. That basically data governance is the thing to understand and make sure to have the information of who has access to your data, and looking back at all these different systems what we had, it's going to be really, really tough to know that. There are systems in place that do that, but it will for sure be one of the main challenges, but also important points for you to look into. So where do we have the data? Also to find the data, do you remember that one table that you need to find, and then you look through and search for everything? Who has access to it? How can you define such a granular access point that you can make sure that, for example, employee A has access to this information, but for example, the same person in the team, in case they're not allowed to, is restricted to access that data. And the more data you get and the more data you have in different ways and in different formats, the higher the challenge in the end gets. And also it's hard to audit. And I think this is something that you are also passionate about, but it's really understanding who actually made a certain decision or made a certain step towards the data is also something of high importance. And then, of course, once you use that data, once you have your machine learning models in place, to have this governance on how the model and why the model decided on in a specific way is also something that should be kept in mind.
So I was 22 years an IT auditor, so I was passionate, but all the audited people wasn't passionate. That's right. And auditing a system, one would say, well, why? Because all these computers are calculating every time in the right way. Why do you come every year and have a look on it? Who has a clue?
we didn't like the auditors as well.
Ah!
We're like, okay, make sure
So I'm
everything's
now on
proper.
the other side. It's very important to audit all these systems because everything can change from one day to another. We have new updates from our software. We have new updates from the operating system. We have a new system in the area of the middleware. We have a virus, maybe. Yeah. So it makes sense to have, let me say, an impression how my system should be, and then audit it if it is like it should be. And this is not only for artificial intelligence systems, it's also for the traditional IT systems. So when I know what the result of a specific IT system should be, I need to make a risk assessment. What kind of influences can change the proper result of the software or the whole IT system?
Can I ask for maybe a specific case? How does an audit look? What are you exactly auditing? It needs to still be abstract.
I especially was an auditor for accounting systems and for banking, mobile banking systems. And we came every year and had a look what versions of the different systems on the servers are implemented. We had a look if there could be, with a penetration test, a security hole. We had a look which data are processed and if there are many errors occur. We had a look on the database, which is in back of this, how many people can have access to it and change the data in the database, for example. Yeah, and this is only, I would say, 1% of all of our auditing.
Did you apply specific rules, or was there individual for every customer? Or did they all?
Yeah, first of all, if you're an auditor, you need to make a risk assessment and have a look on the overall system and say, okay, specific risk can occur to this system. And then having this risk, you prepare your own audit table and then go all these through. But if the system is, for example, many companies have SAP as an accounting system, you have your standard procedures to audit the system because the customizing of the SAP system is very similar and from version to version, and you only have to look at the customizing of the SAP system and you then know what the results will be. So this is very easy. If you have a standard software, you can have your standard auditing table and go through all these tasks. Okay. Yeah. So let us have a look on the different types of data. Or do you think all data is similar or the same? No. So in companies, we have different and very different types of data, and you need to maintain this data in a different way. So I have documented here 7 different kinds of data. There might be a little bit more, but these are the main data, and these data are in every company. So first of all, we have metadata. Metadata describes the format of other data or the version of a database. And this information you need to, for example, to give it to your auditor, as we had discussed before. And the auditor then knows, okay, it's, for example, the database Oracle in the version 9.10.11. It's a very long number. Yeah, so many versions. And then they can prepare their audit tables accordingly. Or if you have an interface with another company, for example, to send them electronically invoices, you need to give them the format of your invoice. Otherwise, it would not open. So metadata describes the way how data are and which with tools or software we can open, for example, a specific file. The second is reference data. And you all know these data if you ever had booked a flight, because you don't type in Wien or Vienna, and normally you use a reference, how our airport is named. In our case, VIE. So every one of you who ever had a flight booked knows that in the US there's another airport with the same name. It has the same name, Vienna. So to identify very properly and for every cases, you need to have a reference data. And these reference data, for example, for our airport is VEI. So reference data have more than only that you can identify in every case is the right thing which is behind. You can use it to make sure that the information is proper, because you can say a reference data for me has only 3 digits. And so you can have a look on the input from the customer or other users if they are only 3 digits. And if there are not, you can say, okay, this input data is wrong. So reference data is very useful. It stands for sometimes a whole explanation, and you can use it to higher the quality of your data. The third one is structural data. And this describes how your company is being structured. So for example, the marketing department or the accounting department, how many people are there, and you can structure it in a digital way and give this information on a digital way to another person. And as you see, there are different, or there might be different owners who are responsible in the company to have this data in every time in a good quality. Because if you have data, you need it in a high quality, otherwise you cannot use it. So the structural data will be in the responsibility maybe of the accounting department, and they will make sure that in every time it is in the right way. Even if another department need this data. Yeah? The reference data are more data which will be, or where the data owner is outside the company. For example, the airport number, you can say which airport digits will Schwächert have. So there are other people who are responsible that the link between the airport and the reference data of the airport will be. And these data are not so many moved. So they are in a long term the same. So you can use it. You can use it to have the data in the right way. And you have the data which is behind in a high quality. So the fourth point is the transaction structure data. Let us come back to the invoice example. If you send another company your invoice in an electronic way, you need to say them on what position are the specific information. For example, the invoice number, the date of the invoice, or the amount. So in the structure, you describe on which position the specific data will follow up, and the transaction data, we have it in the 6th one, will follow them. So if you would like to imagine an Excel sheet, so you have in the first row the transactional structure data, and below you have the transaction data, which comes through. Then we have the, which is very, very important for both, you have other people who are responsible for this data. So for the transactional data, you have it in the accounting department, and they need to make sure that the quality is very high. And for the transaction structure data, you have the development team or the IT department who is responsible for it. Yeah? So if you have a project to send another company invoices in an electronic way, you need to go to more than only one department to make this happen. Yeah? Then very quick, we have the inventory data. So that is the amount what we have on the on our lager.
We have on stock.
What we have on stock, right? In different ways. So as in the other example, we have here another department which is responsible for this data. And the last one is the audit data. For all real specific and sensitive data, we need some things like a log file where all the changes on this data, which we have above, is being logged, so that we, as an auditor, or the company people who will have a look on the quality of the data, can see when these data are changed. So these are specific different kinds of data, and you need to be very carefully in your company when you use specific data of them, because there are different responsibilities. There are specific methods to higher the quality of all these data, and you will use in normal big data projects more than only one of these. So coming now to the difference, I would say, of big data projects to normal or to the old-fashioned IT systems. Maybe you all know these objectives. So we have on one side the business intelligence, which is very much past-oriented and asks, so what has happened in the past? So when I was at an auditing company, we came every year to audit the annual financial statements, and we looked every time in the past. So everything we were interested in was when were the data changed, were they probably connected to build the balance sheet and the profit loss, and were there any problem in the access of these data. So this is very past oriented, and they try to predict something in the future. So this is what the controlling and the risk management department are doing, but only on the data which was booked in the past. On the other side, this is what we do since 5 years, I would say. So it's more business analytics. It's future oriented, and we think about, okay, when our past was processed in that way, what is being needed that we have better results in the future. So we have to look at statistic models. How can be the future predicted? And we need to use the right data from the past to feed these statistical models. We cannot use every data from the past. We need to select it very carefully, because some of our customers might be no longer in our business model, or we have a new business model with very specific requirements, and we need to select the old data very carefully. Otherwise, garbage in, garbage out. We will not have very good results for our future predicted. So,
and then basically, if we look at the companies that are successful, so we heard Zalando, we heard actually Amazon as well, who use machine learning and data science in their product. So it's integrated basically in their product. What we can see is that there are different companies and enterprises on the maturity curve. So not every company, not every enterprise is mature enough to go in that direction. On the left side, so the gray part is actually the part where most of the companies are super successful already. So they have the data, they clean it, they know what happened, basically through the whole reporting, so they can identify what has happened. The challenge occurs then when you move towards the right side, towards the right side, when you have when you want to actually look into the data to predict something future-oriented. So not only look into the data through business analytics and analyze, find patterns, but also have this autonomous way of acting with the whole system. And if we look at Amazon, because it was mentioned before, the autonomous part is basically to give you the next best offer or give you products that have been used by other people based on their clustering, for example, because they are having some certain interests. And this is something that not a person, not a business analyst or whoever has the power to decides on what to place, but it's really the autonomy that you give to tools and to products and software, basically, to hand it over and do that. And as you might also realize is that once you do that, it's really, really important to monitor the whole aspect. Why? Because data changes, things, how we interact with the tool change, and it's important also to capture the whole process. So data science per se is not something that you develop once and then it's over. It can be for, I don't know, a couple of months, half a year, doesn't matter, based on the domain, but it's something that you need to redevelop on and on. And it's something also to put effort on what kind of business use case to look in. For example, sometimes it happens that a company decides, okay, we need a data science team, we have this data and we want to do something with AI. But the thing is that you really need to also spend some time and effort to understand what kind of use cases you want to foster and what kind of KPIs you in the end want to analyze and see the value of AI. Because after 2 years, let's say, then the board comes or whoever is in charge and then asks like, okay, now I have like 3 data scientists, you have these data engineers and everything who is on the project. But what actually happened? Like, where is the value that you're driving? And this is something to also think about is basically know your domain, but also know which kind of KPIs you want to drive in order to understand what this technology and what data per se is actually driving for you and for your enterprise. So the goal is really to move from the left side to the right side. Often what happens is that there's like a gap in between. So you have technologies on both sides, but when it comes to data science, it's really finding the right data sources, finding the right use cases, and then also finding the right people to match and integrate and work towards that.
So, what's the difference and what's the objective of the more traditional IT projects and the big data projects? Let us have first a look on the traditional ones. So we have normally the cost reduction, so we can fire some of the people because we have a very good system, or we have an increase of efficiency for the rest of the people who are employed, or we increase the productivity. So This is what we have in the past more. So we have this look that people are, or systems are here to reduce the cost of the production of our product, of what we sell. But it was more so. It's we have this. We will go with these products in the future, and we make it a little bit better. So we increase the productivity in producing it, but not have a new business model. This is what now comes in. So we have our normal product, like a car, and we put in data and have more value and have more business cases in selling these data. And this is exactly the business model of Tesla, right? So what is a Tesla? It's a computer with 4 wheels, and you can drive really smooth with it. It's very cool. Yeah, it's better than my laptop. With no wheels.
It's actually, we just got one and it was phenomenal. So really nice.
Yes. So, and we have a new business model with it, and we can sell these data, and we can have a look in the future and create new value for new customers, and we can increase our revenue. Yeah. So data is not only, or the projects are not only to reduce any costs, but is to create new value for the own company or for the companies of our customer, and we can sell these data. Yeah? And this is the difference. But to sell data, we need to have a high quality. We cannot sell any data. We need to have very good data for a specific use case. And for this use case, the data quality needs to be very high. And then we can sell it in a wide customer range. So what looks these projects like? So we have the old traditional IT projects. So we have some, we have a project manager, we have some engineers, we have developers, and they program a specific thing. And then the people in the specific department for which the program is used to would be trained, and this is all. The big data projects are a little bit different. We need specific people which have very specific knowledge and are specialists in their area. So if we have here a programmer, it must not be the best programmer of the world. To program a specific software, it's okay to be a middle programmer, and you don't need to study informatics or mathematics or something like that. It's okay if you learned it by your own. So to program these old traditional data, it was okay to don't have any specialists. But in the big data projects, you need to have specialists. And there's for example, the data scientists who know how we handle with data, who have who can imagine how they can create new values from all these data. And we need some people, they know how people react on data. And that's the success factor of Amazon. It's a success factor of Zalando, that they know how we as a customer react on the offer they give us on the, in their user experience way. No.
Yeah. So this is just like there are only examples, but like looking at Zalando, we heard some of the data that Zalando might use, right? We had clickstream data, we had customer data itself mentioned, but we tried to kind of summarize what they can actually achieve with the data that they have. And this is just like exemplary. But as you can see, you could have structured data, unstructured data, semi-structured data, and others. And what that basically means, and we mentioned it before, structured means really like you have those columns and rows, but we could have historical purchases and orders. Why do you need that? It's basically like to understand what others could do, which are similar to you, basically. So use that history on what they purchased to do that. How much of data is used actually, like return data is used to analyze, should that actually be the product, should it actually be displayed to you or not? Like, for example, if you return a specific product like multiple times, the algorithm itself, like their filtering system itself, they wouldn't really suggest it to you anymore because they kind of really want to reduce their costs, obviously. And what they use for that, or like the whole data science projects they have in the end, is more on understanding the sizing, what we have heard before, understanding and predicting return orders or returns basically, but also in the end using unstructured data like voice of customers to kind of do some predictions, or using images of products. So everything that I said, like everything that is not really like could be structured is basically unstructured. So PDFs, images, and everything around that is basically something that that machine learning models, of course, on the scaling level can support with. And this, for example, could also be used for trends. Let's say they analyze and look into your feed. So Zalando has one aspect of giving you trends. And what some people do is just like scrolling down and like looking at what they actually could be of interest. And this is also some data that they track and analyze and use in order to make their whole user experience better. And this is the main idea and the main goal that they have, to really give the user a personalized view of everything from their customer, from their product base, basically. And then if you look at semi-structured data, it could be, for example, customer feedback. It could be that you kind of look into and see how was it rated, is it bigger or smaller? But it can also be that they use other informations like metadata, or like where the item should actually be displayed on your feed, on the catalog. So it's every kind of user will have probably a different view of data. If they look for, I don't know, Levi's jeans or whatever, they will probably have a different view of that than the others. So just for you as an example, because we mentioned Zalando at the beginning as one of the success stories, and they are indeed, and I'm and others are personally like using that because of the way of how they interact with the users. And to kind of move further, we found actually one of the Zalando slides. We kind of did not make it so pretty as them, but anyways, the story is there. So why is Zalando so successful? It's kind of it could be categorized in those three things. One of them, every decision that they do is backed by data. And this is again why data is so important for today's talk, that whatever they do, and if you look at the maturity curve, is again, data is the new oil, but data needs to make sure, like you as managers need to make sure that the data is in the right quality to have that and to use that. Second of all, the tech teams at Zalando are embedded in their business unit. So it's not that they have an IT and then they have like different units, but it's really like whatever they do, it's kind of really integrated in there. And then third, it's not only that they're a fashion or like a retailer, but it's really the process that they're having is going into a tech company. And we said it at the beginning, they claim and say about themselves that they are a tech company. So they sell products, they sell clothes and other products, but it's basically a tech company that they're having. And they have tons of employees and data scientists and everybody who is like really making sure that the most of this data is used. And then if you look at the boxes, two of them are grayed out because why they're so successful, they say it's three parts. First of all, they're giving the customers the best experience in the sense of most of the products, but also the variety. So things change. It's not always the same thing. Second, the whole delivery and payment process is super easy, super smoothless. So this is another like 2 parts which do not really, they have something to do with tech, but it's not specific to that. And then the third part that they say it's a tailored digital experience that they're having. And this is basically like 6 parts that feed into this tailored digital experience. So personalized experience. So if I, Sanja, go into my Zalando app, I have my own kind of views, my own kind of trends. I get product recommendations. I have the option to discover trends. They actually even have their own influencers, I think, that they give basically the content to kind of really share and make it accessible to others. You have the option to follow brands. Let's say you're, I don't know, super Nike fan. So you would be able to go ahead and follow Nike, see the best trends, the best offers, and basically also be one, if you want to be one of the exclusive members to get the best offers first. And then lastly, creating the highlights. So yeah, all in all, Zalando is really moving from not only being the retailer, but also getting and being the tech company that is just giving you this flawless and this really good user experience for that.
So do you think it's easy to make a big data project in your company or in your future company? So there are some statistics, and they showed that 85% of that kind of artificial intelligence projects in the company are failed. And I know it from myself. I saw so many projects failed because you need at the beginning people who have a vision and have the right question. The right question to bring your new business model with the data you might have or will buy or might create. Yeah? To bring it with your data on a new level to the benefit of your company. So, as I said before, every artificial intelligence model will bring up a right answer. But have you get the right question? That's the very big thing. So the good thing of all, artificial intelligence will not kick us out of the company. We are very important in the future too. So people will make for every company the difference. If you are one of the people who can create with data new value for the company or a new business model for the company, you will be a very big success factor for your company. The second thing is, if you have already data in your company, then try to use it to enhance your current business model. If these data are not sufficient because the data quality is not high enough, or you need other data, look if you can use data from other companies, from ecosystems, or share with other companies, or connect data with other companies to have the right information you need for your future business model. So data will create value, but only if you have the right data and high quality in data. The second thing is, the first step is having a vision, asking the right question. If you don't have the right question, you will never get the right answer. And these answers will not be in many cases in old systems, but you need to connect you will create value in connecting your or linking your old data, if they have a good quality, with public data, and then create new value for new business models. This is very important to know that even if you have old data, you can work on it and you can use it then. But without work on your old data or legacy data, you will not get to any successful results for the future. The fourth thing is big data is very different to any IT project which was done in the past. So it's more like a research. You have a question and then try to find out if your data connected with other data will come to useful results or not. Yeah? So it's a try. It's not, you know exactly how it goes, but you need to try if your data can bring the right results. And it's like a research project. You have a hypothesis. And then you need to test if you can bring out useful things about it. And the last thing is, it's not only the result, it's furthermore the learnings of the people who are in these big data projects. They will learn so much things and brings from these learnings and from these trainings so much new insights into the departments, that you can enhance your business model even if you can use the data. So big data projects have a very big focus on learnings, and you must invest in your people to bring the best results and to be competitive to other companies. So we are at the end for today. And now we are open for questions, for networking, and hopefully for your insights, for your ideas. Maybe we can talk about visions and what you would like to make in the future. So thank you from my side.
Thanks also from my side. I hope you can take some parts on and see and explore it with your company where it is. But I think like the last slide kind of summarizes everything on that.
Questions? It's all clear?
Are there any famous data-driven business models which were developed but at the beginning were not clear? Because I mean, I have some questions. They're not asking the question first. They're collecting every data they can use, then they try to analyze and then making something out of it, trying to formulate a hypothesis about it. So it's a little bit different in that case. There are people that use models for example, in Europe, which can be stated.
I think there are more than one question in that. First of all, the business model of Amazon is collecting data in a structured way and using it for connecting customer behaviors to sell as much as products they have. And not only in one area, not only books, but they try to connect it each other. So if you buy a journey, you will get a book to this journey or to the destination too. So I think it's not only they collect every kind of data, it's a very structured way, and they create the ways how the data is being selected and stored. So you have, I don't know Amazon very good, so I have no insights. I don't know how their databases is working and how their artificial intelligence are running. So I cannot proper answer this question, but I'm pretty sure they have a very structured way. They defined all their data pools, their different data pools, and they research how can we bring business from one product to another product. I'm pretty sure they do it.
And just to add there, like for example, Amazon is for sure like they're having a continuous learning journey. So like the way of how they're using their machine learning journey is kind of a bit different, because like they gather the data. For example, let's say they display your product, like people who bought this bought also this, and if you click on this is like a positive feedback for them. So it kind of feeds into the model that it actually gave you a good way. And even if you buy that, it's something that is even more beneficial. Or if you click away, then they kind of analyze it's all the like the click stream data. But this is like a more continuous learning journey. And as Gabi said, we don't have like the insights of what they do. And for the second question, if we have like an example for like a hypothesis-driven use case. For example, let's say in manufacturing, and Austria is a big country with a lot of manufacturers. It's basically the fact, for example, that you want to find out if a machine, based on their sound, if you can predict whether something will fail or not. So predictive maintenance is actually something that is used a lot. And this is a hypothesis that you're driving because you have the sound systems, but it doesn't really happen often, right? Like if a machine fails, this is bad, but it doesn't fail like every day. So you have like tons of data. So you kind of drive this, and then once it happens, or you simulate it, but once it happens, you kind of feed it back and then try to make it better. Hope this helps.
Thank you. Sure.
Other questions? Or is everything clear now? And can you start your own big data project instantly? Okay, tomorrow.
I would be interested in the architecture, the right architecture for basically building like a database where everything is collected, and then you transform those with distributed systems and try to generate data. What are the kind of best practices for the architecture? I mean, we have business, we have on the left side, we have the BI versions where we try to analyze data we already had collected in the past. And we have line of business apps, we have workflow systems, architecture, and a lot of other data generating software. On the right, we try to kind of predict with AI what could be in the future like that. Yeah? So from that perspective, what is actually the best practice to try to collect all this data in one database? And yeah.
I'm just smiling because this is like the work that I'm doing. So basically, if you look at like data warehouses, they kind of were so successful because you had specific options to do. So for example, you could specify who has access to what. You could like really structure that. You could also merge and join different data. You could, or you can basically. You can basically also make sure that if something like happens to the data, to go back. And like the next step was to really have this kind of data lakes, they call it, but in the end it's only like a file system, so it's similar to what you have on your PC, just with the difference that it's somewhere on a server where it's not like not your machine basically, where you can store anything. But the problem with that is that after a while, everybody bumped in the data, and it got like very, very chaotic in the end. And what have like last 2 or 3 years, what was developed was the so-called Delta Lake or like lake house concept. But this is a little bit of marketing for my company, but I'm really excited about this. Is basically that you can put this data warehousing layer, which you had on the left side, now on the right side as well, and basically to integrate it. So basically you need one system to place all the data which is necessary. This does not mean that you should just like move all the data into this file system. It means that you should think about which data is necessary. And this is something that this kind of tech teams join the business teams, for example, approach makes sense because you're joining the domain, like the domain knowledge with like the tech knowledge. And then basically what it gives you is like a cheap storage. It gives you control over who has access, but then it also gives you a super easy way to interact with the data. You don't need to add system 1 with system 2 with system 3 to kind of find this one database that works, but you rather give like everybody who needs access the flexibility to do so. So it's like giving the employee also the flexibility of self-service versus asking somebody, hey, could you please give me the data? And this is basically like the whole data journey that has happened like 40 years ago and where we are now, to have a data lake with the capabilities of a data warehouse. And this is also what Microsoft and Amazon or AWS with all the other like cloud vendors are also handing over. So basically, long story short, having a system that kind of really can integrate both structured data, but also unstructured data, and giving people the flexibility to access it in a easy way, basically, with all the security and everything behind.
Okay, so if there are no more questions, I will say thank you for coming today.
If you have any questions, I think you can send them to us or to Gabriele and Sanja.
Sure.
Happy to have you here and to network a bit, share experiences. Otherwise, have a nice evening. And thanks for coming.